I'm Adam Klaus, and welcome to the Wilkes Land Expedition. It's really great to have you all here.
It's the beginning of a great adventure.
We're going to drill.
We're going to drill deep.
We're going to drill really deep.
Good morning, world. Here we are on the far edge of the planet, looking over Antarctica.
We have arrived to our spot. Perfect.
This is why we're here, to study this huge ice sheet.
I love this machine, though.
I know.
The mission for this expedition is really cool. It's understanding and investigating the history of climate since about 40 million years ago. We're going to be looking at the influence of the ice sheets on Antarctica and when they started and how they have changed over time.
It has been a long time preparing for this expedition. Since the time we started thinking about the science, and as you can imagine in science, after 10 years, there is many new things that come up into the plate. So you have to always keep updating this project.
Try to monitor how much sample you need. Obviously, we want to take just enough.
In the Antarctic is obviously, for everybody, it's sort of a fascinating, faraway place where you only have seen pictures of penguins. And to go there, to be able to go there, is just absolutely amazing, of course.
Thumbs up, it's a start.
Pretty exciting. First core, everybody's here. Ice, ice, baby. You come down here because the science is exciting, but it's not a bad place to work in terms of just beauty and natural history, the marine mammals, the birds. You know, I'm fascinated by the animals I see every day. And I make sure I spend time every day looking outside over the ocean to see what's there.
So one of the missions we have on the Wilkes Land expedition is to discover the nature and the timing of first ice along the Wilkes Land margin, and whether it was glacial ice which first arrived here or sea ice. And we're hoping to validate a climate model such as this, which predicts that sea ice occurred soon after grounded ice sheets occurred along this margin.
Just let it fit sort of exactly.
And then, you know, to understand what the variability was. What causes this ice sheet to decrease in size? What causes this ice sheet to grow? And this is especially relevant as we have seen more and more in the past 20 years, how we have this global warming trend in our Earth. So actually, when we put the proposal, it was more of a scientific curiosity, but as time went by, it became a very relevant societal issue to address.
We've traveled all the way around the world to figure out what's going on.
It's the best day of the cruise so far.
Great cores, great scenery.
Want to see some penguins?
Yeah, it's beautiful.
Ow, ow, ow. I guess.
See the ice cap, 3,000 meters or whatever it is.
I hate this so much. Pretty happy about it.
We have 30 scientists, 15 to 20 technicians, and we're trying to form those into teams that work very closely.
We chose the scientists, some of them we knew their expertise, Many of them we didn't know. The scientists have worked very well together. I hope that this enthusiasm that we all have right now, it will materialize in science.
Is this a daily work of a co-chief, Carlotta?
Yes, this is when a co-chief, hands-on, yes.
The way we proceed is actually that we first look at discrete samples, at single samples, and every single sample represents a time slice in Earth history, I mean, that we can date fairly well. And it really becomes interesting if we add all the information from all the samples that we look at together. So we would ultimately get some sort of movie through time, and we could actually witness how the Earth cooled from the greenhouse into this icehouse world, and we could actually analyze the processes behind this. After processing these samples, this is where we actually look at the dinoflagellates that we got from the original sediment.
Fatty alcohols here.
One of the real strengths of an IODP cruise is that you have these diverse but complementary groups of specialists. So there's the physical properties people, the sedimentologists, people doing magnetism, micropaleontologists, and the geochemists. And all of us are working together to extract different but complementary data sets from the cores. And working together, they might be able to tell us quite a lot about how those sediments were deposited.
As a sedimentologist on the ship, we see every centimeter of core that comes up. The core comes on deck, it equilibrates, warms up to room temperature, goes through some measurement systems. We're usually the first to see if there's some big change in sedimentation or a change in color. Bring your camera, follow my finger right over to this. Look at this thing here. Maybe move over there and shoot at it back this way. So this layer here, it's maybe 2 or 3 millimeters thick. You know, that's probably the death event, the end of the summer. In the Antarctic, we have 4 months of kind of bright, warm sunshine. Warm in this case meaning temperatures slightly above zero. And then all of a sudden it gets dark, it gets cold, the ocean freezes, and the plants die. And when they die, you get this big dump. They call it the autumn dump event. This layer of plant debris sinks to the bottom and it makes a layer just like that.
So all of these groups are working together, and all of the individuals in the groups are providing pieces of a jigsaw puzzle, and then when we put them all together we get a bigger environmental picture, and using all of these techniques we can track changes in the environment.
Well, we're disassembling the first logging tool string, and then Kerry's going to rig up the second one. It's going to go down into the hole and measure the speed of sound waves and collect images of the inside of the borehole wall, so we can tell where all the drop stones are all the way down to the bottom of the hole, and fill in the gaps that were missed by the core recovery.
As soon as we drilled the second site and we went through the main objective of this expedition, that was, you know, to cross, leave the glacial world and go back to the greenhouse world, and we were able to see that we had reached that. Then that was the highlight.
Resistance is futile.
How can that be? You know, how can it be so warm that right here in the Antarctic there will be, for example, crocodiles running around?
One of the big unanswered questions in paleoclimatology is what's going to happen to ice, what's going to happen to sea level as we continue to see these rising levels of emissions. If we go back to the Eocene period, there was little or no ice at all on Antarctica. And we're trying to get the first sediments that are taken just close to Antarctica. And with the biomarker measurements that I'm trying to do, we really want to extract 3 key pieces of information. What was the sea surface temperature like? What was the land temperature like? One of the biomarkers we're using comes from soil bacteria. And also, what was the vegetation and the plant types like that may have been blown off or transported from Antarctica into the ocean?
I find it exciting that we can say something about the history of our planet from fossils and sediments. I think that's important for us to understand how the cryospheric system operated in the past to be able to help predict global climate in the future.
I mean, it's kind of funny, you know, I've always wanted to study climate change by looking at sediment records. That's what brought me down here in the first place. And I wrote my very first proposal to work here, and the reviewers said, wow, we don't even know how the sediment gets to the bottom, so how's he going to interpret climate change by looking at sediment cores? So